Hello everyone. Let's continue with the chapter circles from class 9. Today let us understand the theorems based on circles. Let's look at a circle. Okay. We in the previous video we understood what does the term angle subtended means. We understood the term subtend. Now it could be an angle subtended by an arc or a chord or a segment or a segment. Suppose if this is the arc that we are considering AB. What kind of an arc this is? Since it is less than 180, it is a minor arc. Let O be the center of the circle. If we join the endpoints of the arc to the center, we get an angle that is formed. And this angle formed, the name of the angle AOB or angle BOA, is called as the angle subtended, you can say by the arc or by the chord or also by the segment. I hope you have understood what is subtended. Okay. Can an arc or a chord or a segment subtend an angle only at the center? For that matter, we know that it can subtend an angle at any point on the circle. Suppose we are taking different points on the circle. So this arc AB can subtend angle P at point P on the circle, at point Q on the circle, at R on the circle, or for that matter, any point on the circle. Is it clear? So we understand what is subtend, right? Let's understand the various theorems now. Let's look at the first theorem. The first theorem states, if in a circle we have two chords which are equal, in a circle if there are two equal chords, the two equal chords are going to subtend equal angles at the center. The theorem the first theorem states, equal chords subtend equal angles at the center of the circle. Okay. So let's understand this. When they're saying two chords which are equal, two equal chords means we are going to take two equal chords. Let me mark the center as O. We are talking about two chords, say AB, and we have some another chord, say PQ. Okay. PQ is the other chord. What is the relation between them? They are equal. We are told they are equal. Both of them are subtending angles at the center of the circle. That means chord AB is subtending angle AOB at the center and chord PQ is subtending angle POQ at the center. We want to prove that the two chords are going to subtend equal angles. That means we want to prove that these two angles are equal. Is it understood? So what is given to us? We are given that in circle with center O and radius. Radius could be OA or OB or OP or OQ, whichever you want to write, you can write. I'm saying in a circle with center O and radius OA, we are given that chord AB is equal to chord PQ. If so, then we have to prove that angle AOB is equal to angle POQ. Right? To prove that these two angles are equal, we are going to consider the triangles. Now, the two angles are part of which triangles? AOB is part of which angle? A triangle? In triangle AOB. And angle POQ is part of triangle POQ. If we manage to prove that these two triangles are congruent, then we'll get the angle subtended by them, or these two angles which are part of the congruent triangles will also be equal. So look at triangle AOB and triangle POQ. Can you tell me what is equal? First thing given, AB is equal to PQ. It is given to us. We'll give the reason. It is given. Next, what is given? What do we know? OA, OB, OQ and OP. What are they? They are radii of the circle. Singular form is radius. Plural form is radii. So can I say OA is equals to, let's say OQ? Or if you want to write OP, you can write because all are equal. So I'll say OA is equals to OQ and OB is equals to OP. For both, we can write the reason. Radii of the same circle, radii of the same circle are equal. So what do we get? Triangle AOB is congruent to triangle POQ. By which test, children? We have marked all the sides, corresponding sides equal. So we can say they are congruent by SSS test. And because the two triangles are congruent by SSS test, we can say angle AOB is equals to angle POQ, and the reason will be corresponding parts of congruent triangles. Hence, we have proved that if the chords of a circle are equal, then they will subtend equal angles at the center. These are the two angles that are subtended by these two equal chords. So because the chords are equal, the subtended angles are also equal. Right? Moving ahead, I hope you have understood this. Let's move ahead. Is the converse of this true? What do I mean by that? If we have a circle, okay, if we have a circle and in the circle we have two chords, we don't know whether they are equal. We have no idea whether they are equal, but the only thing that we know that they are two chords in the same circle. AB and say PQ are again two chords, and they both are subtending equal angles at the center. These two are subtending equal angles at the center, means we are given these two angles equal. And we have to prove if the chords subtend equal angles, then the chords are equal. If the chords subtend equal angles, then the chords are equal. Again, the same thing. So, the theorem 2 would be converse of the first. Chords subtending equal angles at the center of the circle are equal. Chords subtending equal angles at the center of the circle are equal. And what is given to us? Are we given that AB is equal to PQ? No, they are just two chords. But what is given? That in circle with center O, you can take any of the radii, OA. We are given that angle AOB is equals to angle POQ. This is given to us this time. And we have to prove that the chords which are subtending the angle. AOB is subtended by which chord? Chord AB. And POQ is subtended by which chord? Chord PQ. The two are going to be equal. Again, chord AB is part of which triangle, children? Chord AB is part of in triangle AOB. Correct? AB is part of AOB. And PQ is part of triangle PQ, POQ. Right? So let us write equal parts. First of all, the angle. We are already given that angle AOB. AOB is equal to angle AOB is equal to angle POQ, right? Second, again, can we write OA is equals to OP and BO is equals to OQ? Similar reasons we'll write. The first thing, reason is given. And the second two, we'll write radii of the same circle are equal. So what do we get? We get triangle AOB is congruent to triangle POQ. By which test? We have AO is equal to OP, this time I've written, and OB is equal to OK. So we have S side, angle side. So we write here SAS test. Now because these two triangles are congruent, can I say AB is equals to PQ? Why? Because it forms corresponding parts of congruent triangles. See, now these two triangles are congruent. So the parts corresponding to it, PQ and AB, they'll automatically become congruent or equal, sorry, because they are corresponding parts of congruent triangles. I hope you've understood these two theorems, children. Thank you.